acid-base titration. Non-face-to-face activity. Changes in the pH of the solution during titration. Instruction to the students. View this video to complete the worksheet below. Number 1. Calculate the pH of solution before addition of sodium hydroxide. Step 1. Calculate the number of mole of HCl by using the formula of mv over 1000. The answer is 0.003 mole. Step 2. Calculate the number of mole of sodium hydroxide by using the formula of mv over 1000. The answer will be 0 mole. Let me illustrate the titration process by using the titration magnetic board. This is the titration magnetic board. Sodium hydroxide as the titrant, HCl as the analyte. Let me represent 0.003 mole of HCl with 3 magnetic pink circles and blue circles for sodium hydroxide. Since there are no sodium hydroxide added into the conical flask, the conical flask contains only HCl. There is no reaction between sodium hydroxide and HCl. So, let's fill up the ICF table and find the excess reagent. Since there is no reaction between sodium hydroxide and HCl, thus there is no changes in the number of mole of HCl. The excess reagent is HCl. Step 4. Find the total volume of the solution and change it into liter. The answer is 0.03 liter. Step 5. Find the concentration of HCl by using the formula of number of mole over the total volume. The answer will be 0.1 molar. And finally, step 6. Find the pH of the solution by using the formula of pH equals to negative log concentration of H positive. The pH of the solution is 1. Let's continue with question number 2. Calculate the pH of solution after addition of 10 centimeter cubic of sodium hydroxide. Step 1. Calculate the number of mole of HCl. Step 2. Calculate the number of mole of sodium hydroxide. Let me illustrate The reaction of 0.001 mole of sodium hydroxide with HCl. 0.001 mole of sodium hydroxide will react with 0.001 mole of HCl to produce salt and water. The pH of the solution depends on the excess reagent. In this case, the excess reagent is 0.002 mole of HCl. Let's fill up the ICF table. The excess reagent is 0.002 mole of HCl. Step 4. Find the total volume of the solution. The answer will be 0.04 liter. Step 5. Find the concentration of excess HCl. The answer is 0.05. And finally, step 6. Find the pH of the solution. The pH of the solution is 1.3. Let's try yourself. Question number 3. Calculate the pH of solution after addition of 20 centimeter cubic of sodium hydroxide. Observe this video carefully to find out the excess reagent for this reaction. Question number 4. Calculate the pH of solution after addition of 30 centimeter cubic of sodium hydroxide. Step 1. Calculate the number of mole of HCl. Step 2. Calculate the number of mole of sodium hydroxide. Let's see what happened when 0.003 mole of sodium hydroxide is added into the HCl solution. 0.003 mole of sodium hydroxide will react with 0.003 mole of HCl. This is known as equivalent point. What is equivalent point? The number of mole of acid is equal to the number of mole of base. There is no excess sodium hydroxide and no excess HCl. The solution is neutral salt. The next drop of sodium hydroxide will change the pH of the solution to become alkaline, and the indicator used will change color. The point where the indicator changed color is known as endpoint. Fill up the ICF table. There is no excess reagent. Step 4. Find the total volume. And step 5. Use the ionic product of water to find out the concentration of H positive produced by water molecule. The concentration of H positive is 1 times 10 to the power of minus 7 mole dm minus 3. And finally, find the pH of the solution. The pH will be 7. Move on to the final calculation. Calculate the pH of solution after addition of 40 centimeter cubic of sodium hydroxide. Step 1. Calculate the number of mole of HCl. Step 2. Calculate the number of mole of sodium hydroxide. Zero 0.004 mole of sodium hydroxide is being added into the HCl solution. You will find out that the excess reagent now is sodium hydroxide. Find the number of mole of excess sodium hydroxide and calculate the pOH. ICF table showed that the excess reagent is 0.001 mole of sodium hydroxide. Step 4. Find the total volume. And step 5. Find the concentration of excess sodium hydroxide. Step 6. Find the pOH of the solution. By using the formula of pOH equals to negative log concentration of OH minus. The pOH is 1.9. Step 7. Find the pH of the solution. With the formula of pH equals to 14 minus pOH. The pH of the solution is 12.1. By using the calculated pH values, you can sketch the pH curve for acid-base titration. Hope this video helped you to understand the topic. Thank you.